Hey guys, in this video I'm going to be talking about the last two functional groups for the organic chemistry unit. So the first one that we are going to look at is the alcohols. All right? What is an alcohol? An alcohol is a type of organic compound that contains a hydroxyl group attached to a hydrocarbon chain. And so hydroxyl is essentially it's just an OH or a hydroxide and that's been attached to a hydrocarbon chain. Now we're still going to use the parent chain and the same prefixes that indicate the number of carbons. So for example, methane, propane, pentane, octane, things like that. That will still be the base, but then what will be different in terms of naming is the suffix. In this, the suffix for an alcohol is going to be an OL, ol, and that indicates that the molecule contains an alcohol group, or sometimes also called a hydroxyl. Okay, so let's take a look at methanol as an example. So methanol, we have that initial part that tells us about the carbon, which means that it is a one carbon parent, I guess. One carbon. And then you have the ol right there, which indicates to us that this is a alcohol. So what this looks like then is that we have our carbon in the middle. Okay, there's that. And then we have this alcohol group attached to it right there. Okay, so anytime you see an OH, or again, a hydroxyl in a hydrocarbon chain, we know that that would be an alcohol. Okay, and then therefore the ending should be the OL. Now, basically all the hydrocarbons that we've looked at before, they can all have this alcohol group. So you can have ethanol, you could have propanol, you can have butanol. So again, the number of carbons is indicated by that prefix. So for example, propanol, pro is 3 carbon chain, and then you have the ol at the end, meaning that is a propane has a hydroxyl group attached to it somewhere. Okay. Now for longer chains, we are going to use a number to indicate where the hydroxyl group is attached. So kind of like with the branched chain alkanes and alkenes and everything, where we have alkyl groups or just other carbons branching off of it, we used a number to indicate where they were. Similar idea is going to happen with an alcohol. The number is going to indicate which carbon atom the hydroxyl is attached to. Okay, so in this case, let's first identify the parent chain. Green here. So we have a carbon chain that is 1, 2, 3, 4, 5. Okay, we got 5 carbons there. So that would be pentane. Okay. The alcohol in this case is attached to this right there. That's where it is. And it's attached to the second carbon in the chain. So then the name for this would be 2-pentanol. Pretty straightforward. It's not so much different. You know, now that you've looked at the branch chains, you kind of had this practice with the branching and where the numbers would be indicated and what that actually means. So in this case, 2-pentanol means that the hydroxyl is attached to the second carbon in the chain, which is right there. Okay, let's do it the other way around where we're actually drawing it out. So in this case, we have the thing given to us and we have 3-hexanol. So first thing you want to find is the parent chain. In this case, hex means 6 carbons. And then the alcohol is attached to the third carbon in that chain. Okay, so let's draw out our parent first. So 1, 2, 3, 4, 5, 6. Okay, and again, the alcohol or the hydroxyl is attached to the third carbon. So right there. Oops. There's our OH. And then just like we did before, we're going to fill everything else in with hydrogens. Remembering that carbon has to have 4 bonds in total. Now this one is attached to the oxygen and these other two carbons. We only need one hydrogen there. And then there's that. Okay? And that is our hexanol. Now, if you do any more with this, you may see them kind of be a little bit more technical. You may see that instead. It means the exact same thing. The reason why they would show it this way is that they do want to specify that the carbons are the ones bonding. If you draw the H second, then it kind of looks like the hydrogens are attached to it. So sometimes you might see it written this way instead. It means the same thing though. Okay? So the last one that we have to look at is the halocarbon, and this one is involving the halogens. So if you remember back to last year in grade 10, or even grade 9, where we learned about the periodic table, a halogen is something in group 17, found on the periodic table, there at that last column before the noble gases. So these include things like fluorine, chlorine, bromine, and iodine. Okay, so a halocarbon is a compound that has a covalent bond, where one of the carbons has a covalent bond with a halogen atom. Okay, now sometimes you'll also see this, if you go further with this, you may see these called alkyl halides. Sorry, I had to think about that. But again, it means the same thing. Essentially, you have a halogen attached to one of the carbons in the chain. Now, naming-wise, it's actually based upon which one of these halogens is attached, as you'll see. And so the prefix will change depending upon which one is bonded to the carbon. So if it's a fluorine, we're going to use fluoro. If it's a chlorine, we use chloro. If it's a bromine, you bromo. And iodine, iodo. Okay. Technically, there are other halogens like astatine, but we generally don't use that in these. They're not as common. So these are the four just to be aware of. Okay, so let's look at these on how to name them. So again, first thing you want to do is always find the parent chain of carbons, and in this case, that is here. Okay, that is a 4-carbon chain, meaning it's a butane. Now, our functional group here is this chlorine, and it is attached to the carbon number 1, the very first one in the chain. So this would be 1-chlorobutane. Right? And again, we're still going to use numbers to indicate which one the halogen is attached to. And since it's the first carbon in the group, it is 1-chlorobutane. Okay? Next one. We have a longer chain right here. Nothing fancy, didn't try to branch these to trick you or anything. But in this case, let's just count out our carbons. There's 1, 2, 3, 4, 5, 6, 7, 8 carbons. So that means is our base is an octane. All right. Octane. Okay. And in this case, we have our bromines here and here. And obviously, you should notice that there's 2 of them, but basically all we're going to do for something like this is use the di, tri, quad, or tetra, and stuff like that. So in this case, we'll first indicate which number carbon they're on, and that is right here, that's carbon 2, and right here is carbon 6. Okay, so then the overall name is going to be 2, 6 dibromo octane. You would have a, since it starts with an O, you don't need to do that second O, you don't need 2 of them. But, it's there in case. But realistically, I would have just dropped it out. So, in this case, we have 2-dibromo octane. Okay? Now, let's look at the other way. And now if we have the name and we want to draw it. So again, always want to start with the parent chain to make your life easier. In that case, it is a pentane. So 5 carbons. 1, 2, 3, 4, 5. Okay? And the halogen in this case is iodo, and it's on carbon number 2. So iodine, remember that's just an I, it's on the second carbon. Draw it there, and now we fill in the rest of the hydrogens. Okay, and that's 2-iodopentane. Now, technically, you can have these attached to alkenes, which remembers the double bonds, or alkynes, the triple bonds. You can have a branched chain, so you may have methyls and ethyls attached to it as well, but that goes a little bit beyond what is expected of you in grade 11 chemistry. If you go on further and take it in university, you will definitely see more of that. But realistically, it's still the same rules. As long as you know your alkyl names, the number of carbon names, and how to find a parent chain, it's essentially the same rules, just you get longer, more complicated names. So you could have, for example, 2-iodo 3-methyl pentane. Okay, and so if I even just were to, as an example, 2-iodo 3-methyl pentane. Okay, basically all we would do is we would have a methyl there added on to that third carbon in the chain. Okay, so it's not overly difficult, it just makes it really long and kind of messy, but it's totally possible for that to happen. You could even have them attached to these cyclic alkanes and cyclic hydrocarbons, so you could have cyclohexane, okay, and that means you have a cyclic one and you have a chlorine attached to it. You can have cyclohexanol, okay, that would be an alcohol that is attached to a cyclic hydrocarbon. Okay, so again, it is possible to combine all of the things that we've looked at thus far, and again, you would definitely do that if you were to take more of it. And of course, you would learn the rules as to the priorities and everything. But again, for our course in grade 11, that's essentially the key things to know there. Okay, so that is pretty much all there is to know about the alcohols and the hydrocarbons. Please let me know if you have questions. This video did correlate with the student notes on alcohols and halocarbons, so you may, if you want to go back and rewatch it so that you can fill in those notes, that might be helpful too. But I will also post some practice ones for you to try this out as well. But again, that's pretty much all there is to it. So hope that made sense, and if you have questions, just feel free to ask. Have a good day, I guess, or something. See ya!